All right, here we go. Henry Saba, his favorite musician is Saba Ranks, one of my favorites from back in the day. He has no idea who that is. I'm showing him how old I am. All right, so Henry is ex Citadel, ex Lazard, deeply technical in the world of data systems, infrastructure, platforms, automation, all the geeky stuff that I love. So we share that and have that in common. We were introduced by a good friend of both of ours, Carrie Jakewith. Shout out Carrie, who also has the Lazard background, which is how we met. I love Lazard. And we were talking, and he's like, "Hey, have you seen that illusion of thinking paper from Apple? It's something you want to pay attention to." And I was like, "No, what is it?" And so he flipped it to me. I looked at it. I was like, "Hey, would you be willing to come on AI with Alec, do a fireside chat? We can talk this stuff through." And he was kind enough to say yes. So here's Henry. And what are we going to do off the top? Let's start with, why is this paper so interesting to you? And what do you think are some of like the big takeaways and ideas around, large language model versus large reasoning model? And remember, my audience is either super technical or the kind of opposite, but super intellectually curious senior business folks. So let's figure out how to navigate the territory in between and talk through this. Henry, go. And you can tell us about Saba Ranks too, if you'd like.
Let's move on from the Shabba ranks because first time hearing the guy's name, I will look him up afterwards,
You're
guaranteed.
going to dig it. He's good. He's
Yeah.
very good.
What kind of music?
Reggae, hip hoppy, a little mix, a little this, a little that. It's good.
Cool, cool. I can dig it.
Yeah.
Yeah. Look, I think first and foremost, let's get the definitions on LLMs, LRMs out there. I like to illustrate them actually with
Yeah.
kind of little games and analogies. So, Alec, if you can just help me out here and help me finish these sentences, right? Um, Actions speak louder than.
Words, my man. Show me, don't tell me.
Correct. Um, what about how about it takes two to?
Tango?
That's correct. You passed 2 out of 2. Um, so, Alec, look, these are known English idioms that we've all learned over time, or a lot of us have. And different people might know different idioms, right? But LLMs or large language models combine all the idioms and like basically everything else we've learned and documented over time. And they've become great at pattern matching and playing this game of predicting what word should follow a sequence of words. Now, LRMs or large reasoning models, to illustrate that, I mean, a great way to do that is just by asking someone, well, first and foremost, like, what is 10 plus 20? And okay, they'll immediately say 30. Makes sense. But what's 9 times 19?
A
That
little
might
more
take
difficult.
someone a bit
Yeah.
more time to solve. And, one way to solve this is by multiplying 9 by 20 to get 180, and then subtracting 9 to get 171. Okay, that process of breaking down a problem into its components is the foundation behind LRMs, large reasoning models. In the AI world, that process is called chain of thought, and it kind of looks like a human reasoning through a problem. And I say looks like because that's kind of what this paper talks about. Um, it's this idea of, are they actually thinking or are they mimicking the way we think? Um, yeah, that's kind of the basic definition.
I like that. And I'm gonna double click into that because I think some folks probably have some experience with the perplexities, the chat GPTs, the Claudes, the Google Deep Research, and what have you. And I think most people are starting to pick up on, you can kind of see the machine's thinking as you ask it more open-ended, kind of complex questions. And so one of the things, shout out Deirdre Bosa from CNBC, who's phenomenal and always has her, fingers on the pulse of all things in tech. But there was a paper, or excuse me, there was an article that she published, I think it was a few weeks ago, maybe it was a couple of days ago, actually, now I'm thinking about it, where she was stepping into this. And she was pointing to this paper that we're talking about. And she was like, hey, the AI industry might have a $1 billion blind spot. And so I think the implications of this paper, and some folks have strong opinions about, maybe this is a little bit of a way of Apple, hopefully distracting the market from some of the challenges it's facing in enterprise AI. We'll leave that over there. You can read the article from CNBC if you want to learn more about that thought process and perspective. But the bottom line is, Jensen Huang this was actually quoted in the article. Jensen Huang said something to the effect of the reliance on reasoning in these intelligent systems go forward is 100 times the amount of compute, more or less, I'm paraphrasing, than what we were seeing as it relates to training these LLMs. And so it's a long-winded way of giving you the stage here, Henry, to kind of give the context from a business perspective, from an implications perspective, industry perspective. This notion of how good or not so good these systems are and these LRMs are at thinking is at the center of so much hype and reality to an extent of where the enterprise AI game is going. So the question I would ask for you to kind of think about and maybe unpack for the audience is like, when you read the paper and you looked at the way they use these more narrow puzzles and so on and so forth to kind of stress test that thinking and that logic, walk us through a little bit of some of the kind of interesting insights that came out of it, such as once an answer was correct, the model kept working on answers or finding answers that were actually wrong and wasting compute. Again, my words, not yours. But I would love for you to kind of like get a little specific, if you want, here on some of the stuff in the paper for those that either aren't going to read it and or don't really want to read a research paper like you and I geek out on, so that they can get the kind of the TLDR, from you.
Okay, sounds good. First, I want to say I believe that this paper shouldn't be completely shocking to anyone. It's just a reminder that the problems we're throwing at these language models are probably not hard enough, despite the value we still get from using them. Personally, I believe that there's some signal here on how much redundancy exists in the world in enterprise use cases. Because the moment these models saw a level of complexity that they were not trained on, their accuracy collapsed.
Yeah.
Apple called this, one reason Apple gives as to why this happens is because there's data contamination in the cases where AI performs well in. So once they bump up the level of complexity of a problem to, a decent level, they just no longer know what to do and just hit the eject button and peace out. So yeah, I think honestly, first and foremost, if you hand a problem to an LRM and it can't solve it, I would say don't be frustrated. It just means you're solving something that's cutting edge and probably pretty interesting. Other things I will say is I believe this paper is also a commentary on what happens when the gap between marketing and product has just gone too wide. Because on one hand, you have Meta talking about super intelligence. I mean, if you look up Meta right now, you'll see all kinds of articles about, how much it's paying for the people it's hiring. But then on the other hand, you also have Apple showing that these models can't solve complex problems even when you give them the actual formula to do so. And that's pretty interesting. So really what we have right now is memorization at scale, as CNBC mentioned it, or large memorization models. For business use cases, what I will say is, just a moment, Alexa's talking.
Alexa picked up on your conversation and might have an opinion.
Dude, honestly, sometimes I'm like, it's got to be listening to something.
I mean, come on, right?
It's like,
Of
are
course.
you talking about me? I'm not even integrated with LLMs yet.
That's a whole other topic, but yes.
That's a
Yes,
whole
I'm sure.
that is a whole
Yeah.
other topic. But yeah, look, I think ultimately this paper said. I mean, you said a lot in earlier, so I have so much I want to talk about. But
Yeah.
ultimately, I think that this says something about where we are with reasoning models. They're not really thinking the way we do. They're just imitating us really well, and they're just not able to get, as Apple proved, they're just not able to get that light bulb moment in certain scenarios. And I think that this inconsistency is a red flag if you're relying on these systems in a high stakes environment. And from a business perspective, that matters a lot. You might be getting plausible looking output that's actually drifting away from the correct answer, for example. And you won't know unless you audit every step using AI monitoring tools, systematic evals. The biggest takeaway from the paper, I think, is their inability to solve generalizable problems. Um, and honestly, that's why Jan LeCun, Meta's chief AI scientist, said just recently that we won't be reaching AGI by scaling up these LLMs. We need to fundamentally change the architecture behind them.
Well said. And you know, I'll kind of play something back for you just because I wonder if the audience might find this as interesting as I do. Is what you're essentially saying, that gap between, let's say, the collective, you know, component parts of AI systems, the technical capabilities, you know, is in one place, and some kind of folks refer to this as jagged intelligence, et cetera. And then there's the way that things are being positioned and marketed, whether it's the way that an existing company that's a big player in the space is trying to go to market and get big enterprises to work with them versus their competitive set, whether it's things that are said in part to drive and motivate, you know, capital raising efforts. But it sounds like the reality is, the good news is, right, these systems and these component parts are wildly useful and exciting and interesting. You just kind of have to know where to use them and what problems they're really good at solving today, and how to build the architecture and the systems, which goes back to your background, of course, to put them in place. So give us a practical example, if you could, of a way to that you know the audience might understand and appreciate. Is like, how should folks be thinking about putting these pieces together to solve problems in a business setting? It might not be the sexiest problems in the world, or they could be. It's up to you. You can go with whatever you want. That you feel confident that these component parts are capable of solving in light of some of the paper's findings.
Yeah, I mean, I think um, what we're going to see more of now are these tightly scoped AI agents, rather than trying to shoot for one agent that can solve it all. And so one example is a project that I'm currently working on, which is in the recruitment space actually. And so
Yeah.
there's a third-party recruitment firm that I'm talking to, and they have over 100,000 resumes, and a big problem that they have is this process of matching resumes to job descriptions and vice versa. Given a job description, get me all the relevant resumes. And right now, it's a very manual effort. It's a pretty difficult effort, even like very inaccurate, because say you're hiring for a software developer, they would probably just search software developer through their resumes and see what matches come out. But you can also have software engineers or data engineers or so on, and they're also good fits. Um, so when I first saw this problem, I was like, okay, that's a great use case for a RAG, retrieval augmented generation. And so you use vector search to effectively do kind of like a fuzzy matching, a more intelligent fuzzy match. Get the right resumes, throw them at the recruiter, and just make that process more efficient. Also make it more accurate, because really it's a shame if you don't hire somebody merely because you didn't see their resume in the first place. Um, so when I first started my company, I actually didn't envision working on AI products initially, but now I'm seeing, in use cases like this one, you need to start thinking about putting AI at the core of the systems that you build. Um, there is still a lot that we can do with it, as I was saying earlier. It's just um, the more cutting edge, like really frontier level problems that we're trying to solve. What Apple is saying, what I'm saying also is we're probably not at the stage yet where it can solve problems that it's truly never seen before, and just thinking through those novel problems.
I love that example, and I remember when you shared that with me. Let's go further on that, because I think this is very universal, right? So some people would say that some candidates are very good at interviewing, and or some folks have really great resumes, or they look like great resumes, and they're able to get a job that perhaps they aren't nearly as capable of executing on as they were getting in the door. It's a little bit like selling versus delivering, right? And then the flip of that is talent leaders and HR leaders in these companies, how are they supposed to keep up with how simple and easy it is via throwing a job post or job listing up on LinkedIn, all of a sudden thousands and thousands of these resumes, and then there's this whole thing in AI slop, et cetera. So I wonder if you could help the audience understand, because you mentioned RAG right there, right? So unpack, if you could, using this example, the nuances of how you can introduce data sets that can make that LLM and therefore the agent and the system that you're designing wildly more nuanced in its understanding of signal versus noise and who's got the goods in a certain job role or whatever versus who's just got a great resume in terms of the wording and so on and so forth. Because I think that's really interesting, because I think inside of that is a great way for folks to understand the dynamic of, as you said, kind of a supercharged agent that is very purpose built for a very nuanced and specific topic. And one of the big parts is the RAG component.
Yeah, so when I first heard about this problem for that recruitment firm, the first thing that came to my mind was, let's just take all the text from these resumes, throw them into a single prompt with ChatGPT, and let's see, what it spits out when given a job description. As you probably imagine, Alec, it's going to well exceed the context window of what ChatGPT could handle. And then I got into this next topic, which is, okay, well, how about we take these models, fine-tune them, basically train on top of what they've currently been trained on, and then get a very specialized model after, adding the new data on top of the old data, aka transfer learning, which many people who have worked with machine learning models have used. I then realized that's pretty expensive. It's very time consuming to both do as a one-time setup and then as a recurring setup. And then I said, okay, now I understand why RAGs exist. It's precisely to solve for both of those problems that I mentioned earlier, and obviously others as well. And so the idea there is you just take all that extra data that you want the model to be aware of, and you vectorize it. Throw that in a vector database. And we don't need to know the details behind vectorization, but the idea is it's just encoding this data in a way that the AI model, the LLM, can query. And so that's basically how you start off with. You have the documents that are encoded, and then now you're in a situation where whenever you throw a new prompt at the model, it can query that vector database for the closest matches to the prompt that you're giving it. But it'll still, let's say it'll take you from, in my case, let's say 100,000 resumes to a few hundred. And now you're in a stage where you can actually put those resumes into the context window, and then you can actually have a more refined output using the LLM. And so the whole idea here is just taking a big data set, shrinking it further, and when it's of a decent size, now you can use LLMs with their intelligence capabilities to shrink that even further into a truly refined data set that you can use.
I love it. And I think that's a perfect explanation. And then to just layer one thing on, here we go, is like that right there, I think is a great example of how humans plus machines collaborate so much better than the opposite or the alternative, because now when that recruiter sits and actually wrestles with 5, 6, 10 resumes and or has conversations with folks, their collective mental model as an organization of what they're really looking for has now been understood by this system that therefore then enables the human to step in and start to have really interesting conversations and spend all that time talking it through with folks that are super qualified, and that everybody wins in that instance. So, all right, last question, which I promise it won't be about Saba ranks, because that would be funny, and who knows what you would say other than like maybe the equivalent of your favorite musician.
I probably have to put that in ChatGPT before you ask the question.
That's true. That is true. But Help us understand from your perspective as somebody who's got the depth in these systems and this paper, obviously illuminated a lot of the challenges in where the current state of reasoning actually is. How much longer do you think it's going to take until some of these challenges are resolved? And where's it headed in the next, like, let's just say 6 to 9 months? Like, what do you get especially excited about through the lens through which you see the world? You don't have to see it through anybody else's lens. It's just, I'm talking data infrastructure, systems, automation, and the stuff that we're talking about. Like, what gets you pretty excited, and what are you keeping an eye out for over the next 6 to 9 months in the ecosystem's maturity?
Yeah. So Sundar Pichai actually went on Lex Friedman's podcast
Yeah.
not long ago, and now they're talking about this concept of artificial jagged intelligence, AGI. And I think that's the right way to look at it. Like nothing or most things in life aren't binary, and so it it takes time to get there. And really, artificial intelligence is both a moving goalpost, but it's also a spectrum. And we're slowly moving there, but we're not going to get to super intelligence, from one day to the next. We're going to start optimizing on models in certain ways. A few months ago we got pretty good image generation. We also have reasoning the last few years. So we're slowly making progress in like different domains and different architectural foundations and thinking. I think we're going to push forward in this. We're going to slowly see those jagged edges, push more, and we're going to see more jagged edges. So that's, I think, the initial trend that we're going to go to. And then I also think we're going to start seeing a proliferation of these agents that are tightly scoped, that have proper evals, proper monitoring around them. Yeah, we're just going to have to see ultimately where we're going to go after that. But in the near term, I do believe that we're just going to have to build these very refined, very purpose-built agents for specific use cases.
I love that. We're going to leave it on that. We should come back another time and talk that through because I couldn't agree with you more. And I think there's so much hype around agents, agent this, agent that. And I love your answer there. So thank you, Henry, so much for taking the time. And we'll get you back on here again soon. I know the audience is going to really dig this one. So thanks very much.
Yeah, thank you, Alec.
Take it easy.